we're going to look at what is scientific notation. Okay? Scientific notation, guys, it is a compact way of writing very large and very small numbers. It's traditionally used by scientists and mathematicians, and I'll correct those spellings. All right, we're going to look at two examples, guys, of scientific notation. We're going to look at the examples on how to write these numbers in scientific notation, and then we're going to go back and talk about why they are written that way. Okay? So anytime that you have a number, guys, and you're writing it in scientific notation, you need to understand that your decimal is here, right there at the end of the number or the value. Okay? If it's in standard form. Okay, and you're going to end up placing that decimal one place in front of your last number. Okay, so really, our last number is 2. We're going to place the decimal there in front. So it's going to be 2.84. Now we're going to multiply this times 10 because each of our values in our number system are based off tens. Okay, and that 10 is going to be raised to an exponent of how many places that decimal was moved. So 1, 2, 3, 4, and 5. So this would be 2.84 times 10 to the 5th. Okay? Now, same concept for example 2, except here now we're looking at a number, guys, where it is smaller than 1. And we talked about last week, anytime that you have a number smaller than 1, the exponent ends up being negative. Okay? So here we're going to take the decimal and place it one number in front of our last number that's not 0. So we're going to have 2.68, and that's going to be times 10 raised to the power of, and how many places was it moved? 1, 2, 3, 4, 5, and 6. All right, so we're looking here, guys. We need to know and understand, which we do, that my decimal is right there. Okay? It is also here and there on that one. Now we're simply just going to take this and move it the amount of places for my exponent to put it in scientific notation. So my base number here, again, like we talked about, is going to be all my numbers that are not 0. So here we'll have 7.5, and that's going to be times 10, because our number system is based off the tens. Now, how many place values has the decimal been moved? 7. So times 10 to the 7th. We good there? Let's skip that. Okay, because, all right, so now like here on number 2, we're going to have to show all of those pieces or parts of those place values. So this one has got to be 2.08. We've got to show that 8 there. So that's going to be times 10. Okay, but the decimal was moved 2 places. So it's 2.08 times 10 to the 2nd. Okay, now, all right, so number 5, we'll have 9.07 is my base number times 10. And how many place values has it been covered up by? That would be to the 5th. Okay, everybody good there? All right, now we're going to look at values that are less than 1, so we know my exponent is going to end up being negative, okay? So we take the same approach here, guys. My base number for number 2 is going to be 8.52, okay? 8.52. And that's going to be times 10. Okay, but now, how many place values has my decimal been moved? 1, 2, and 3. Keep in mind that it's got to be a negative 3 because this value is less than 1. Okay? All right. And then we start looking at number 4. Pretty simple. 4 will be for 0.0, and you can put the decimal 0 if you like. It's not going to change the end value, times 10 raised to the power of negative what? 2. We good there? All right, and then number 6, we've got 6.1 times 10 to the negative what? 6. Okay. All right. Now, let's look at 7, 8, 9, 10, 11, and 12. Okay? All right, here we're taking these that are in scientific notation and putting them in standard form. All right, so now we're looking at numbers that are in scientific notation and we're going to put them in standard form. Okay, keep in mind if my exponent's positive, that's going to tell me that more than likely my value is going to be more than 1. If they're negative, it's going to end up being less than 1. Okay? All right, or really less value than what it's showing anyway. Okay? All right, looking at number 7 here, we've got positive 2, so we'll move the decimal in a positive direction. So 1, 2. So that one would end up being 200 and what? 54. All right, we're going to go straight down to 9. Okay? We've got 9, and my decimal is going to be moved 5 places. So that's going to cover up for one of the ones, and we got 4 more to go. Now, what's going to fill the rest of those places? Zeros, because we don't have any value or any pieces or parts of those 10. So 1, 2, 3, and 4. Okay? All right. Number 11, we've got 1, and now the decimal's got to be moved 3 places. So that's going to be 1, 4, and then 1 more 0 for that. All right, everybody good there? All right, let's look at number 8. Okay, now we're moving my decimal towards the negative direction. Okay, so this would be 2 places, so that's going to be decimal 0, and then 6 will be my other one, and then 7. Everybody agree there? All right, and then here we will have decimal. Now, take note, guys, it's moving 4 places, and sometimes we can get a little caught up or overwhelmed with the number of zeros that we put. Okay, but just know, when we move it 1 place, it's there in front of the 5. So how many zeros are we going to have left to place? 3. So we'll go 1, 2, 3, the 5, and then the 8, 8. Okay? All right, and then here, 1 place is going to be decimal 3, 8. Oop, 3. Everybody good there? All right, so we're fixing to start looking at adding and subtracting scientific notation. Okay, so instead of having to write out these 7, 8, 9, 10 digit numbers and add them together, it's going to be compact in a little more condensed version. Okay, so the first thing that you guys need to know is that please make sure your exponents are the same. And this goes back to our exponent rules, guys. The first that we talked about on last Monday, your exponents and your variables must be the same. Okay? Now, we are going to use what we call LARS. Okay? But I'm gonna hyphen it. Okay? LARS. Okay? And all that means, guys, is that if you add to your exponent to make them the same, that's all that means. When you hear left add, okay, anytime that you add to your exponent, that decimal is going to be moved to the left. Okay, if you subtract from your exponent and make it less, okay, you move your decimal to the right. That's just to get our exponents equal so we can combine our like terms. Okay, so don't get way confused. Now, if you want to type this over here, we only use this when, okay, adding and subtracting numbers in scientific notation. Okay, so that's the only time that we will use this. Okay. All right, so while you guys are adding that to your note section, guys, we're going to quickly go ahead and look at 13. Okay, first thing that we need to look at is, are my exponents the same? Do we have the same value raised to the same exponent? Do we? Yes. Okay, so simply, all we have to do is add our base numbers. So that's going to be 3.4 plus 5.2. And 3.4 plus 5.2 is going to give you what? So that's going to end up being 8.6 times 10 raised to the power of what? 2. Are we good there? Pretty simple. All right, let's look at 14. Okay, and I'm going to skip around just a little bit. Let's go to 14 here. Here is one, guys, where our values are not the same. Now, a tip of advice for me, guys, is the exponents that are not the same, I would take the smaller one and raise it to the larger one. That way you don't have to do any adjusting or changing to make it in scientific notation. It will automatically be in it for you. Okay? All right, so here we want to adjust the 6, raise it to a what? 7. So to get that 6 to a 7, did we have to add or subtract? 6 to a 7, you do what? Add. So add tells me that I move my decimal to the what? Left. Okay? So we're going to move the decimal to the left for this one. Okay? So then we end up with 9.5 plus decimal 11. And that should equal 9.61. And that's times 10 to the 7th power. All right, looking at 15, guys, we have negative values here for my exponent. Okay, but again, it doesn't change what we do. But what you do have to be careful here is make sure you adjust the correct one to make it a little bit easier in the end. So if you're looking at these, my exponent's -4 and -5. Which one is really the smaller one? -5. It's less. So we want to move it, adjust it to where it's the same as -4. Okay? So here we want it to be a -4. And how many did we have to add to it to get it to -4? Just 1. So we'll move our decimal place 1 place right there. Okay, remember if we add, go to the left. All right, so then this ends us with 7.24 plus 0.318 equals, and then when you add those together, you should get 7.5. No, excuse me. Yeah, 7.558 times 10 to the -4. All right, now 17 is another example, guys, where our exponents don't match up. Okay, except now there's a difference of 2 between them, but again, it's not going to change what we do. So we're going to raise the 6 to an 8 to make our exponents the same. Okay, but again, how many place values did we have to add to that to make it an 8? We had to add 2, so we still have to move our decimal 2 places. So 1 and then 2. And don't forget, when you have that right there, that gap, that extra place value is filled with a what? With a 0. So here we have 2.5 plus decimal 042 equals, add these together, we get 2.542 times 10 raised to the power of 8. Now, we're going to look at one here, guys, that's got a subtraction sign in it. That's probably going to be your biggest mistake when you start doing these, guys, is you just start adding, and then you forget and realize that you don't always add them all, you subtract them. Or you can subtract them, or you can multiply and you can divide. Okay? So here the concept stays the same. We want to make the 11 a 12. Understand that my decimal's here. If we add, it's moved 1 place to the left. Okay? So now we have 5.0 minus 0.9, and that should equal 4.1 times 10 raised to the power of 12.